Hello everyone, welcome to my channel GATE-ISSR-VIZAG. Myself is Dr. ISR. So started my GATE training in the year of 2003 and taught at various premium GATE academies. In this session, we'll be discussing about classical scheduling algorithms and evaluation. So as we know that there are two categories of CPU scheduling algorithms. One is preemptive nature, the other one non-preemptive nature. Preemptive nature is nothing but forcefully releasing of the resources by the existing process, and non-preemptive nature is the particular process, whichever it enters into the CPU run state, it has to release its resources voluntarily upon completion of CPU time and burst time, that is IO time. And what exactly the meaning of first come first serve? It is based upon arrival time. Whenever a process is created and process is given an ID, which is a unique, also known as a job ID, task ID, or process ID. And this time, when we are talking about first come first serve, it is completely based upon arrival time of the process. So it noted down that when the process is entered, when the process is exited, that complete history is available. So this particular scheduling algorithm is completely based upon arrival time, and that too, it is a what? That too, it is a non-preemptive nature. It is a non-preemptive nature. That means once it enters into the CPU, then it cannot be forcefully removed. It has to release or come out from the CPU on its own. That's why it is completely based upon arrival time of the process, and it is based on what? Non-preemptive nature. So first come first serve. Its a criteria is arrival time, and its a mode of working is a non-preemptive. But sometimes what happen? Imagine there is a process ID like P1 and P2. Arrival time of the processes are 0 and 1. What does it mean by this? The mean by this is nothing but process 0, that means process 1 is arrived at time 0, and process 2 is arrived at time 1. So that's how ready state scheduling them in nice manner based upon arrival time. So arrival time is a mandatory so that you could able to easily schedule the process from ready state to run state. And another example I want to speak here. Sometime the arrival time of the processes may be same. Arrival time of the process may be same. What does it mean by this? Exactly at time 0, two processes have come, P1 and P2. Now there is a conflict. Which process it has to processed, which process it has to send it to CPU. Then especially short-term scheduler is having a problem what to do here. And in such case, if arrival time of any two processes is matched, then immediately you select the process and send to the CPU which is having a lowest process ID number. In this case, once again P1 will be released to CPU because its arrival times are same. Then when arrival times are same, based upon the lowest process ID is processed first. So these are the two principles is supposed to follow throughout the CPU scheduling problems. So one is they have arrived at different time intervals. The other one is that they have arrived at same time intervals. Let us do problems based on these two scenarios. So let us say there are 5 processes, and processes are given number P1, P2, P3, P4, P5, and arrival times are also 0. What does that mean by that? All have arrived at a time 0. P1 is there, P2 is also there, P3 is there, P4 is also there, P5 also there. All the 5 processes have appeared to the ready queue. Then I said, what is the rule I said? Whenever arrival times of the process are same, you need to take the process which is having the lowest process ID. And that too, we are talking about a FCFS algorithm, first come, first serve. It is one of the finest algorithm, very easy to schedule, but only one problem is there, that is a convoy effect. What is a convoy effect? We will see in upcoming. So here, all the 5 processes have arrived at the time 0, arrival time 0, and they are right now in ready queue. And ready queue removes the conflict by taking the lowest process ID. So in this case, what happened? It scheduled the process P1 because it is having the lowest process ID. And what is the burst time? CPU time here. Here, burst time is nothing but CPU time only. So how many units it's needed? It's needed how many units? 4 units it needed. So P1 is executed for 4 units of time. By 4, P1 is completed. We also record completion times also. By 4, it is get completed. So well, the remaining processes are P2 and P3 and P4 and P5. Again, they have all arrived at the same time. Again, the uh, short-term scheduler try to remove the conflict by taking the lowest process ID, which is nothing but P2. Now P2 is executed for 3 units of time. So by 7, P2 got completed. Here, CT stands for completion time, BT stands for burst time, AT stands for arrival time, TAT stands for turnaround time, WT stands for waiting time. So it executed completely and releases its resources. Now the rest of the process is P3, P4, and P5. Again, there is a conflict. All have come at the same time. Now P3 will be picked by the ready queue because its process number is lesser than the rest of the processes. Now P3 got executed here and P3 needed 5 CPU cycles. By 12, it got completed. So the completion time of the P3 is at 12 and the rest of the 2 processes are P4 and P5. Now P4 get executed because it is having the lowest process ID. It needed 6 units of cycle. So by 18, it is completed. The only process which is left in the ready queue, that is a P5. Now, whenever there is a single process in ready queue, there is no necessity of the CPU scheduling algorithm, exclusively round robin. Yeah. And there is an exception, especially in round robin, that it has to switch from one process to other process. But generalized principle is that whenever ready queue has only one process, there is no requirement of any CPU scheduling algorithms. CPU scheduling algorithms only to provide the fairness among the processes just by choosing only one process to send to CPU. Now, the P5 get executed and P5 needed 2 units of time. So by 20, it is also completed. Now, what is the turnaround time? We learned the turnaround time is nothing but exit time minus entry time. Entry time of the process minus exit time of the process is known as turnaround time. Entry time is 0. Exit time is nothing but 4. Exit time is nothing but completion time. Entry time is nothing but arrival time. So that's it. So completion time is a 4 and arrival time is 0. Its turnaround time is 4. And the next exit time is a 7. Arrival time is 0 and its turnaround time is 7. Next, exit time is 12 and arrival time is 0 and 12 is its turnaround time. Exit time is 18 and arrival time is this. 18 is the turnaround time. Exit time is 20, arrival time is 0. So 20 is turnaround time. So waiting time. What is the waiting time? Waiting time is nothing but in turnaround time minus how much time you are into CPU. Turnaround time, entry time minus exit time, how much time you are together, 4 units of time. Among the 4 units of time or out of the 4 units of time, how many units you are busy with the CPU? 4 units I'm busy. Therefore, 4 minus 4, which is 0 waiting time. Exactly. Because the P1 has come at 0, immediately it is processed. Therefore, there is no waiting time. But rest of the process, if you understand, P2 has come at 0, but it is taking at where? 4. There is a waiting time. And even you talk about P3, P3 has come at 0, but it is picked at 7. So there are some waiting times for other process other than first process in this example. Now, therefore, what happened? P2 turnaround time is 7, but its time spent with the CPU is only 3. Therefore, 4 units waiting time. Then 12 units are turnaround time for P3, but it is executed by the CPU only 5 units. So 7 units is a waiting time. Then 18 units is turnaround time. It is only busy with the CPU 6 units, so 12 units are waiting time, idle time. Then 20 units is a turnaround time. It is busy with CPU 2 units, so 18 units are your waiting time. So altogether we want to sum it and average it because we want to find out average turnaround time and average waiting time. Both we want. In exam also you will ask this question, average turnaround time and average waiting time, because the CPU scheduling main motto is a reduction of average turnaround time and average waiting time. So what is the sum here? 4 plus 7, 11 and 23, 33, 41, 61 by 5 process. And waiting time is 4 plus 7, 11, 11 plus 12, 23, 33 plus 8, 41 by 5. That is your answer. So let us move on to next example. Yeah, see, this example is having a different arrival times. Most cases you will get this kind of problems, 100%. You never get the same arrival time problems. Imagine 0, 1, 2, 3, 4, their arrival times, and P1, P2, P3, P4, P5 are their process IDs, and how much time they are busy with CPU? 3 units, 2 units, 1 unit, 4 unit, 3 unit. Now let us pull them into ready queue. At 0, no other process has come except P1. So P1 is arrived at a time 0, so I have taken it and it is executed 3 units of time nicely. Then it is get completed at 3. It is get completed at 3. Now imagine during execution of P1 from 0 to 3, there are other processes also have come. What are the other processes have come? P2 has come at 1, P3 has come at 2, and P4 has come at 3. That means few other processes the ready queue has taken them. P1 already completed, the next process is P2, and next process is P3, and next process is P4. 3 processes have come during the execution of the first process. So P1 got completed. Now there are 3 other processes are there right now, P2, P3, P4. There is no problem whatsoever because their arrival times. Arrival time of the P2 is lesser than P3 and P4 because it has come at 1. I have come very early, first come, first serve fashion. Then immediately the ready queue dispatch the P2 to CPU state. And that too, it is FCFS algorithm and it is a non-preemptive nature. Once it is entered into the CPU, you cannot pause it. Therefore, P2 is executed for how many units of time? 2 units of time. So it is completed by 5. It is completed by 5. Now there are 2 other processes left, that is a P3 and P4. But imagine during this time from here to here, there is a one more process have come at time 4, that is nothing but P5. It also arrived. So pull it to ready queue. Now among these 3, again there is a race. Which process I need to send to the ready queue? Which process I need to send from the ready queue to the run state? There is no problem because we are having arrival time concept. So P3 has come at a time 2. So P3 is executed for how many units of time? 1 unit of time. So therefore, by 6, it is completed. Then after that, two other process, P4 and P5, there is no need to cross check anything because all processes have dumped here. Now P4 get executed 4 units of time. 4 units of time, P4 is executed. So P4 is get completed by 10. Then after that, the last process which is left over is a P5. Then P5 get executed. The time units required here is 3. Then by 13, it got completed. That's it. All the completion times we got put. Now turnaround time. Turnaround time, I said exit time minus entry time. Exit time is 3, entry time is 0. This is a turnaround time. Then exit time is a 5, entry time is 1. This one. Entry time is a 1, so turnaround time is 4. Exit time is a 6, entry time is 2, then 4. You need to look at 80, arrival time. Exit time is a 10 and entry time is 3, so 7 units is a turnaround time. Exit time is a 13 and entry time is a 4, so 9 units. Waiting time. Waiting time is nothing but, so exit time minus entry time. During this time, what a process is doing, is it under idle or is it busy? That's the meaning of that. If it is busy, it may use a bus time. So turnaround time 3 minus it is busy with how many times? How many units? 3 units only. Its waiting time is 0. Then after that, its turnaround time is 4. It is busy with how many units? 2 units of the CPU. So 2 units are waiting time. This is a 4 and it is busy with the 1, so waiting time is 3. Then it is a 7, it is busy with CPU 4, so 3 units. And this is a 13, it is busy with CPU 3, so 10 is a waiting time. That's it. You need to find out average turnaround time and average waiting time. So average turnaround time 3 plus 4 7, 7 plus 4 11, 11 plus 7 18, 18 plus 9 27 by 5. And what is the waiting time? 2 plus 3 5, 5 plus 3 8, 8 plus 10 18 by 5. So simple as that. Response time. What is the response time? When you arrive, when the CPU first identified. So the CPU picks time minus your arrival time is your response time. You observe here, P1 has arrived at 0 and the CPU also picked at 0. Response time is 0. Next, process P2 has arrived at 1, but P2 is handled at 3. Therefore, 3 minus 1. Again, I am telling you for process P3, P3 has come at 2, but P3 is taking over by the CPU at 5. So 5 minus, you have arrived at 2, so 3. Then P4 is arrived at 3, but P4 is handled by the CPU 6. So 6 minus 3, 3 is your response time. Then the next one is P5. P5 has come at 4, but P5 is handled by the CPU is at 10. So 10 minus 5, which is a 5 is your response time. So this is how to solve whenever the process have arrived at a different arrival times. So let me do another scenario. Process ID P1 and P2 and P3. Arrival time 0, 4 and 8. Bus times are 1, 2 and 3. So this is a different question. So we'll be shocked by seeing this kind of examples. So let us see the Gantt chart. So this is your Gantt chart. At time 0, only one process is arrived. That is a P1. So P1 is executed for how many units of time? 1 unit of time. So P1 got completed at 1. Now, there is no other process have come till 4. Therefore, CPU is idle up to 4. And 4, which process has come? P2 has come. So only one process is there. There is no cross-checking of any kind of scenarios, which process I need to pick from ready queue to send to the CPU, because only one process just left it. So P2 is executed for how many units of time? 2 units of time. By 6, it got completed. But at 6, no other process is there. This is completed, this is completed, this is only incomplete one, but it is not arrived when the CPU reaches to 6. Therefore, CPU is idle till 8, and it is get satisfied with how many units of time? 3 units of time. Then by 11, it's also get completed. In this case, turnaround time. What is the turnaround time? CT minus AT. 1 minus 0, 6 minus 4, and 11 minus 8. Waiting time, you know. What is the waiting time? Turnaround time minus burst time. Turnaround time minus burst time. This is a 1, this is a 2, and this is a 3. So turnaround time is a 1, 1 minus 1, your waiting time is 0. Turnaround time is 2, 2 minus 2, its waiting time is 0, because as soon as it has come, CPU is processing it, and 3 minus 3 burst time, your waiting time is also 0. So in this case, average turnaround time and average waiting time, let us see. Average turnaround time, it is a 12, 12 by 3 process. Average waiting time is how much? 0. See the beauty of this problem. So what is idle time of the CPU? This is very, very important. What is idle time of CPU? Idle time of the CPU is nothing but here. It is spending how many units? 3 units here. It is spending how many units? 2 units here. So 3 plus 2, your idle time. 5 units is idle time. So this is a different scenario. So let us do carefully. So please observe. So at 0, no process is there. Please observe. At 0, no process is there. So it is idle. At 1, any process is there? Of course, P4 has come. Only one process. So let us land the P4 into CPU. And P4 needs how many units of time? Only 1 unit of time. By 2, it is completed. And exactly at 2, anybody is there? Yes, there is a one more process. This one, it has come. So P4 is landed, P2 is going, and it is required how many units of time? 5 units of time. And it is get completed by 7. So P2 is also completed. During 7, see, we have reached from 0 to 7. 7, almost all processes have come. It has come at 3, it has come at 6, it has come at 4, it has come at 5. So let us land all the process now. So I'm landing rest of the process except P4 and P2. So P1 is there, P3 is there, and P5 is there, and P6 is also there. So among them, which process have come earlier? Which process have come earlier? This process has come earlier, P3. So let us send P3 to CPU. So P3 is executed for 3 units of time, and by 10, it get completed. And the rest of the processes are there in ready queue, P1, P5, and P6. Out of 3, which process have come? Out of 3, which process has come earlier? P5 has come earlier because P6 has come at 5, P1 has come at 6. So we will process P5. So P5 is executed how many units? 2 units. So by 12, it got completed. Then the only two other processes are left, P1 and P6. Among them, which process has come earlier? P6 has come. So let us process P6. P6 is executed for 6 units of time. So by 18, it got completed. The only one process which is left, that is P1. So P1 is a schedule now and it requires 4 units of time. By 22, it get completed. That's it. Now turnaround time, entry time, exit time difference. So 22 minus 6, and here 7 minus 2, and here 10 minus 3, and here 2 minus 1, and here 12 minus 4, and here 18 minus 5. That's it. This is a 5, this is a 7, this is the 1, this is the 8, this is 18 minus 5, 13. So waiting time, turnaround time minus burst time, 4, minus burst time, 5, minus burst time, 3, minus burst time, 1, minus burst time, 2, minus burst time, 6. So 6 minus 4, it is 2, and 5 minus 5, it is 0, 7 minus 3, which is a 4, 1 minus 1, which is 0, 8 minus 2, which is 6, 13 minus 6, it is a 7. Response time, let me record with a new color, response time. Response time is nothing but when the CPU identified the job for execution minus when it is arrived. So P4 is scheduled at 1. Let us see from P1. So P1 is scheduled at 18. When it has arrived, at 6 it has arrived. So 12 is the response time. And P2 is scheduled at 2. When it is arrived, at 2 only it is arrived. So response time. And P3 is scheduled at 7, but it is arrived at 3. And P4 is scheduled at 1. P4 is scheduled at 1, it has arrived at 1. Immediate response. And P5 is scheduled at 10, but it arrived at 4, 6. And P6 is scheduled at 12, and it has arrived at 5. So 7 is the response time. So this is how to do when you get this kind of problem. So my dear friends, I'm giving you a challenge question to you. You do on your own. Any doubts you have while finding out turnaround time and waiting time, you may comment. Then we will discuss this question if there are a good number of comments in the next sessions. So thank you for watching my channel and click the bell icon for latest updates.